Good afternoon. My name is Andreea Dumitrașcu, and I wish all the students and everyone connected a warm welcome to this Connect University Junior session on the fascinating world of artificial intelligence, more exactly demystifying artificial intelligence for students. Connect University is the knowledge-sharing flagship initiative of the European Commission's Directorate General on Communication Networks, Content and Technology, in short DigiConnect, that aims to inform the public about the latest digital trends and challenges, which are highly linked with relevant policies. This European Commission project is a trademark for learning, networking, and debates, raising awareness about the ongoing digital transition and preparing the society for the future changes, reaching out to Europe and also beyond. Connect University Junior represents a Connect University initiative, which is committed to equipping the young generation with the awareness and skills necessary for the digital age, because now, more than ever, digital literacy is imperative. Connect University Junior aims to inspire the young minds, helping them to seize the endless opportunities of digitalization and make the most of the emerging technologies. Today's focus will be on artificial intelligence, technology already part of our everyday life and increasingly becoming more integrated. Early education in artificial intelligence comes with many great benefits. It's preparing the students for a strong presence in the job market, is boosting creativity and also problem solving, and sets them on a path towards positive societal change. Today, our speakers will tell you more about these key aspects. So we invite everyone to connect on Slido with the code AI now. I repeat, the code for Slido is AI now, where you can comment and ask questions, and our speakers will reply to you accordingly. Also, we invite you to use the hashtag #ConnectUniversity when sharing insights on the event on social media. So I'm pleased to present the speakers of today's session. So we have Mr. Martin Ulbrich, Senior Policy Officer of Artificial Intelligence Policy Department and Coordination of DigiConnect, European Commission. We have Ms. Alexandra Przegalska, Vice Director and Associate Professor at the Kosminski University and the leader of AI in a management program, also a former MIT Research Fellow, AI expert and world-class keynote speaker, and also Mr. Hugues Bersini, Professor of Computer Science at Université Libre de Bruxelles. So without further ado, I invite our colleague Martin Ulbrich to start his presentation and to tell us more about the European approach to artificial intelligence.
Good afternoon. Can you all hear me?
Yes, I confirm that we can hear you and we can see you as well.
Okay, wonderful. Just trying to make sure that everything works fine. Thank you so much for giving me the opportunity today to talk to you about AI. Can you actually see? Let's get this way. Okay, now it should be fine. Okay, so my name is Martin Ulbrich. I work for the European Commission. I've been here for a long time, actually, 25 years or so. And I work in the Department for Digital Affairs. We have a much more complicated name. We call this Communication Networks and Electronic Content. But fundamentally, we're really the DG, which is working on digital affairs. DG means Director General. It's a bit like a ministry in the national government. So it's a big government administration unit of about 1,000 people working mostly on digital affairs. Digital affairs, in our case, includes everything from 5G networks, so latest generation networks, internet access, telecommunication regulation, also content, media policies, all kinds of things. And so within this very large department, we have a small department which is dealing with artificial intelligence. We have only altogether about maybe 40 people. But of course, although it is still fairly small in terms of how many people are working on it, AI has become an incredibly important topic over the last couple of years. Now, most of you, or many of you anyway, are students, and you may think, because it has been like this for the last 5 or 6 years, that AI has always been an important topic. But that isn't true. Until about 2015, AI was really only a topic for specialists. I mean, there were people who have been working on AI for a long time, But if you were talking about digital affairs, about new technologies, you were talking about the networks, you were talking about cloud computing, you were talking about all kinds of new approaches. But artificial intelligence wasn't really one of them. There were many people who thought that artificial intelligence was never going to take off. AI, from now on, I call it just AI, has been around for about 60 years, so from the mid-50s onwards. And it has had a couple of times periods when people thought that AI was really, really impressive and could do lots of things. And then these didn't quite pan out the way it was supposed to be, and then people abandoned it. And then 10, 15 years later, some researchers made a breakthrough and attention focused back on AI. Since I'm the first speaker, before I can tell you about the European approach to AI, we have to discuss a bit what actually AI is. So what is AI? AI is first and foremost, and I think that's a bit counterintuitive, it's two words. And that's very, very important because AI, a large part of the debate about AI is really only because of the name. AI is a software, it's a programming tool, which can also be called, or at least large parts of it can also be called by other names. For example, you could call them deep neural networks. Now, none of you probably will today go to a speech on deep neural networks. It's just not very interesting. It sounds like something for geeks, for people who are inclined in technology. But by calling it artificial intelligence, all kinds of people all of a sudden get interested in that. Partly because this is an impression, intelligence, which makes it sound like human already. Intelligence is something that we typically associate with humans. So artificial intelligence makes it kind of sound like artificial humans. And that, of course, is something which we're all interested in. And then also because over the years, we have seen many Hollywood movies talking about AI, which, of course, is built again on this initial association between artificial intelligence, humans. And therefore, we have seen lots of science fiction. And in the science fiction, we've seen lots of AI characters. Now, many of these characters have been either called AI or they essentially are AI. For a long time, people were thinking about the characters from Star Wars. Very classical, but also already very, very interesting because you have in that movie you have two kind of AI systems. One of them is a robot which is humanoid, so it looks like a human, it talks like a human, it moves like a human. That's clearly the idea that robots and AI are modeled on humans. And then you've got the other robot, which of course is not like a human. It's a bit like a human, but it's very different. Then we've got plenty of other movies. Very often they are very dystopic movies where you have computers taking over the world, whether it's an iRobot or The Matrix. And that also is one of the reasons why many people, when they talk about AI today, they have a certain fear. They believe that AI, may take over the world, that their machines are going to take over the world. And of course, there are many more movies. I've just put a couple of on here. Now, one question I always like to ask people if I have actually a group of people sitting in the room is like, which is the most AI-like character in all of the movies? And the answer, to my mind at least, is Spock. He's actually human or a Vulcan, but Spock is a perfect characterization of AI. He's perfectly logical, doesn't have any emotions, and doesn't have any sense of humor. This is much more like AI than many of the so-called AI characters which we have seen in fiction. So keep in mind that AI is just a piece of software. Actually, it's many pieces of software. And as such, it's nothing like a human. You can put AI into a machine which looks like a human, but that doesn't make it work like a human, and it doesn't give it to run the world. Now, what is AI if it's not any of these? Well, this is AI fundamentally. It's lots and lots of data, and lots of charts, and lots of relations between the data on the charts. This is how deep neural networks work. You give a system plenty of data, and by plenty, I don't mean 5,000 or 10,000 or 20,000. We're talking about millions and millions and billions of points. To give you an example, and this, of course, is increasing very rapidly. 3 years ago, the largest models in AI had about 1 billion 100 million parameters. So there were 100 million data points which were in the model. These were the biggest. 3 years later, we're talking about 175 billion parameters for a simple model, well, for the most advanced model. So the number of parameters of data has increased by a factor of something like 2,000 in just 3 years. And the numbers now are huge. I mean, 175 billion is a number with so many zeros that it's going to be hard to write it on the screen. So when we're talking about big data, which is what your AI need for, it's very, very big data. And that's something you really have to keep in mind. Now, the way AI works, and by AI in this particular moment, I just mean AI as in deep learning networks. So if you have a network and you give plenty of data to that network, and the network then figures out by itself what is the relation between these points of data. This is what these days about 80% of AI is mostly on this AI. You have other technologies for AI which are more traditional, but this is really what has made AI exciting. That you don't actually have to program everything yourself as you do in a traditional computer program, where you program something like if X then Z. So if the person is taller than 1.70 meters, then you have a bigger seat, for example. That's very simple traditional computer algorithm. In AI, you don't have that. You have some very basic algorithms. You give the system lots of data, and the system learns by itself. And that is very, very difficult. Many of the things which are extremely obvious to humans are very, very complicated for computers and AI systems. For example, trying to distinguish a muffin from a puppet from a puppy. It is obviously something which we can do very quickly. Taking these 6 pictures, it takes you about 5 seconds to figure out which of them you can eat and which of them you probably shouldn't eat. Of course, the computer is going to have many, many problems in trying to distinguish between those two. Because fundamentally, an AI system, you will try to identify the features of the different pictures and then try to find out from the features how to classify it. And as long as the features are very similar, such as 3 black points and a lot of caramel color, then it's going to have huge problems in identifying these, in correctly separating them into the 2 different categories. So when we're talking about AI taking over the world, and some people still do that, we should keep in mind that if it ever was realistic, which I don't think it is, we're still very, very far away from it. Even very simple tasks for humans, very simple tasks are very complicated for AI systems. Of course, AI systems, just like any digital systems, can be extremely good and much better than humans at very specific tasks. But that is something very different from a general intelligence that humans have, which are not necessarily very good at a specific task, but however can perform very many difficult and very many different tasks at the same time. So why do we think AI is good? I mean, that is a first question. As I said, I work in the Department for Digital Affairs. We have lots of technologists and we talk to a lot of business people, and they all think AI is really great because it gives you new business opportunities, because it's exciting, because you can do all of the sudden things that you cannot do, that you could not do before. And then if I go outside to talk to other people, they're kind of afraid of it for the reasons which I've mentioned. But we overall, I think it is justified to think that AI will improve our lives. Just let's have a look at a couple of examples. One of them, first system is self-driving cars. Every year in Europe, we have about 30,000 people killed on the roads. If you have self-driving cars, and you cannot have self-driving cars without artificial intelligence, you will get rid of something like 90% of that. AI is not perfect, so you will probably still have some accidents, but you probably, it can be estimated that you will get down by 90%. So you would save 27,000 lives a year. That's a very good reason to think that AI is something which we should be investing in and we should be encouraging. Another field where AI is very promising is medicine. We have seen it now in COVID. Many of us are getting the vaccinations, which have been developed by AI, partially, not entirely. AI is a tool; it doesn't think by itself. It doesn't do things by itself. It is used by people who know their specific fields. So in development of medication, AI is very useful. AI is very useful in diagnosis. especially when it comes to rare diseases. If you have your common standard disease, which a doctor has seen 100 times, then probably a doctor is much better. But if you're coming to a rare disease, which a doctor hasn't seen very often in his life, then maybe getting assistance from AI is going to be very helpful. AI is extremely helpful in surgery to reduce the time in hospital, to reduce the damages surgery has to do on the human body by reducing the cuts, etc., etc. It's also very, very useful in calculating the dosification for treatment. So if you need to take medication, how much medication do you need to take, when do you need to take it? That is something where AI can help you a lot. Now, most of these things, you may have noticed, are things that anybody could in theory do if they had enough time to do that. So if you have enough data and if you have enough time to go through so many data, you could actually find out the perfect dosification of your medication. You could find out that it's maybe more efficient if you take it at 9:30 rather than at 8:30 in the morning. Or maybe it's 6.3 rather than 6 tablets that you have to take per week. So it is something which, in theory, anybody could do. But of course, in practice, there's so many data, and you need so much computing power. Well, you need so much time to do that you actually need to do it by computing power. And even if you have to program it, if a computer had to do it the traditional way, it wouldn't work. It's only once you've got AI to do the things that it actually is possible to do them on a large scale. Talking about AI, just taking the medical field, if you think people are getting less sick because of better treatment, they're getting treated faster because of better diagnosis, you have less surgery, you have better medication, etc., you can easily come to a result where AI extends our life by two years of healthy life on average. So that's a very good reason, I think, to support AI. And of course, AI is something which you can apply anywhere. As I said, it's a software, it's a technique. You can use that to build cars or planes more efficiently. You can use that to fight environmental damages, to reduce energy consumption, you name it. Whatever it is that you want to do, you can do it with AI. And by the way, of course, AI is already being used right now for many things that you may not notice necessarily. So if you go to, let's say, Amazon and you buy a book and they recommend you another book, that's based on AI. If you listen to a song on Spotify and they recommend you another song, that's based on AI. If you go to Google and search for something and they recommend you certain solutions, that's also partially based on AI. So there's a lot of AI around, much of it in places which you don't notice. And AI is something which really can be applied everywhere, and I think that's something we have to keep in mind. It's however much focus we want to put on certain areas where AI right now seems to be the most promising. As you may have noticed, I think medical field is the most important. It is something which can be applied everywhere, and therefore there will be many areas where we don't even which cannot even think about of today, but where we will eventually apply AI in a very useful way. Now, as I said earlier, talking to my colleagues in the technical and business environment, they all think AI is great. Many other people are concerned about it, partly because they've seen too many movies, but also partly because there's some real concerns about AI. One of them is that it makes certain things possible which previously weren't possible. Most famous example is that you can have much more surveillance than you had previously. So if you have, for example, a camera running on a main street where you have tens of thousands of people running around every day, and you have a traditional system, it's not possible to use all of the data. So there's a certain, even if you film people, there's a certain anonymity guaranteed because it's just impossible to keep track of all of them. AI makes it possible. You can actually have a face recognition system which runs in a public place and where you have, let's say, 100,000 people coming a day and they can track all of them. And that's a bit coming back to the dystopia. So AI is, AI is a tool, and therefore it can be used for many good purposes. It also can be used for a couple of not so good purposes. Plus, AI also has some challenges in the ethical area. One of the most famous is that some people think that AI may discriminate involuntarily because AI is based on data. So if the data is not exactly what you think it should be, then the result AI may be discriminating. And of course, then you also have got ethical dilemmas in how you actually, what are your preferences? So, for example, assuming you have certain medical treatment where you have 80% success rate, and then along comes an AI system which gives you a success rate of 90% for men, but only 85% for women. So then you would have a discrimination of men against women because men would be treated better than women. So that's in principle contrary to all our principles. On the other hand, both of them would be better off than without AI. So in that case, you would have to decide, so what's more important, better treatment or the principle of equal treatment? A similar issue is that AI, because it is trained on lots of data, it's not always easy to understand how it actually has arrived at a solution. So you don't actually understand why it is sometimes that it proposes something. And that, of course, is a concern because people like to understand why things are the way they are. And also, if something goes wrong, AI is not perfect, then you should be able to find out why it went wrong. And if you cannot do that, then that's a problem. And if some damage has occurred and you cannot find out what went wrong, you don't actually know who has to pay for the damage. So that's another problem. And there again, we get into a dilemma. Very simple. You imagine you have a medical operation again, 90% success rate for a system which you don't understand, but 99% for a system where you do actually understand. 90% for a system which you do understand, so where you know exactly what the system does and why it does what it does. But 99% for another system where you don't really understand how it works. So in the first case, if something goes wrong, you know how to deal with that. But in the second case, you have many more cases where it doesn't go wrong. So the question then becomes, what do you prefer? And there again, you have to strike a balance between, on the one hand, explainability and on the other hand, efficiency. So there's a lot of ethical dilemmas involved in AI, which is why we actually had an expert group to discuss it for a long time, and they came up with guidelines for what you want to do in AI. Very quickly, I also would like to touch upon a third topic, which is not entirely specific for AI, but where AI also does play a role, and that's, of course, the impact of digitization on the labor market. We know that machines displace people. That's actually a very good thing in many cases, because the jobs which they do are much better. It's much preferable that humans don't do it, like in coal mines, for example, or other very dangerous places. And also because typically the jobs which disappear, the people who had them then get other jobs afterwards in other areas where they're more productive and get even, or have at least traditionally been better paid. The concern with AI is that so far, in order for digitization to have an impact on a specific job, it had to be a job which was very repetitive and which was easily codifiable. So you had to be able to tell the computer exactly what it had to do. So if A, then B, and then do the next step, and then here comes the next step, and here comes the next step. So you had to be able to write it down, and it had to be repetitive because it's quite a lot of effort to write all of this down. So it's only worth it if then afterwards the computer does it plenty of times in order to amortize your investment. Now AI, as I mentioned earlier, actually is able to find patterns and find solutions for itself. So it doesn't have to be a job which has to be so repetitive, and it doesn't have to be something which you can entirely codify. So AI, to a certain extent, shifts the border from the jobs which can be digitized or automated between the jobs which can be automated and those who can't. So previously, we had people losing jobs which could be automated, and then those people moved up to other jobs where they were better paid. If you push the border too far, it's the concern that maybe in the end there will not be enough of the other jobs around. It's a long discussion. Many economists will argue that in the end we will always find new jobs, but then of course that might take some time, and some time again is not a couple of weeks; it might take a couple of years. And if you are one of those persons who's lost his job and then only finds a new job 5 years later, that's a big problem, and we should keep that certainly in mind. We don't really deal with that very much in the AI, in our specific AI policy, because it is really an extension of a problem we have across digitization and across automation. And so it's more integrated into the policy of digitization and automation. Oops, sorry, that was the wrong one. Why is it going backwards now? Yes. So let me recall the baseline argument. AI, the European approach to AI, I think, is best summarized in 2 words. It's yes, but. Yes, we like it, but we are concerned about about certain things. So AI is good. It's good for consumers because you get better goods, a better variety of choices, etc., etc. Medical consumers, car drivers, I talked about them. It's good for businesses because obviously you have plenty of new products which you can sell, so that's good for your business. And it's also good for the public interest insofar as it saves, as it prevents people from dying on the roads, as it reduces pollution, etc., etc. On the other hand, AI also creates some risks for the fundamental rights. So we were talking a bit earlier about your right to actually understand how decisions are taken, which affect you. Right to non-discrimination if there's a different treatment between different groups. Privacy, for example, is also easily affected when we're talking about face recognition. And so for safety, I said earlier, if you get self-driving cars and they get the death rate down by 90%, that's very good, but it still leaves you something like 3,000 people are going to be killed if it's actually 90%. It still leaves you 3,000 people going to be killed on the road, and they will be attributed to AI. So you actually have a number of people who might be killed because of the machine, and that, of course, is a big problem. So we have to address that. So really, the important thing to remember here is that our policy approach is yes, we like AI, but there are certain things we have to address. Now, AI, our policy. We've been doing our policy for the last 3 years. Last year, we issued a white paper, and we asked for public comments. Sorry. And we got many of them. I think that's the key message of this slide. We had more than 1,200 comments from all over the world. So that's quite interesting. I mean, obviously, most of the comments we always get are from Europe, and within Europe from the big countries. That's kind of standard. But this time we actually got comments from India, from China, US, UK I would expect, but countries like Syria and Iraq. So it's clearly a topic, AI and AI regulation is a topic which is extremely important to many people across the world. We also got a fairly balanced number of responses from the different social groups. So we had lots of citizens, just simple citizens like you and me, who submitted a comment. Plenty of business and industry, obviously. We had civil society organizations. We had academics and public authorities. It is also very widespread in terms of the kind of stakeholders which commented upon us. I mean, just to give you an idea of what it means, 1,200 in previous public consultations, we often got like 100 or 200 or 300 comments. Here we got 1,200. So AI, as I said, has been a very important topic, at least for the last 5 years. Everybody's talking about AI, and AI regulation is something which very many people are taking very seriously. There are plenty of them who think somebody should be regulating it. Some people think we should not regulate. Obviously, people on both sides of the debate. The European Union will propose some kind of regulatory framework next week. So I'm afraid I can't tell you today what's going to be there because that's going to be next week. I would invite you to have a look at, if you're interested, have a look at the newspapers or on the Commission website next Wednesday, 21st of April, which is when the regulatory framework is going to be published. Thank you so much.
Thank you so much, Martin, for presenting us the EU angle. Meanwhile, we also run some questions on a Slido related to which key technologies behind artificial intelligence, for instance. And we see that the majority of participants replied correctly, so machine learning. And also we started to receive also questions via Slido. So I'm going to address to you, does artificial intelligence make us more vulnerable given the amount of information that is out there and every one of us? And also a similar question, can artificial intelligence be hacked?
Sorry, I'm just trying to get rid of all of this here. Well, does AI make us more vulnerable? It's a good question. I think every technology makes us to a certain extent more vulnerable because we rely on that technology, but it also makes us healthier and wealthier. So it's a double-edged sword. If you have nothing, you're not vulnerable, but if you have plenty of things, then of course you are more vulnerable. So I don't think AI makes it specifically more vulnerable, but it's certainly true that the more sophisticated society becomes, the more vulnerable we are. That's why also at the European Union we're trying. Recently, we have been putting a certain focus on resilience, so on the resistance to external shocks, which comes a bit obviously together was to a certain extent connected to the COVID crisis, because there we realized how many things, how easily things can go wrong, and it's also partly due to the fact that many of the tools that we use in AI actually are not produced in Europe, so there's a certain strategic vulnerability in Europe. Can you repeat the second question?
Can artificial intelligence be hacked?
Oh yeah, of course, everything can be hacked. I mean, that is something. Cybersecurity is a very important topic, not just for not for AI, but for AI certainly as well. Yeah, whatever you can build, somebody else can destroy it, and whatever you encode and encrypt, somebody else can crack it. That is something we certainly have to be very aware of. Yeah.
Many thanks. There are also other questions on Slido, but we will leave them for the Q&A session. And now we will move to the next presentation. Hence, I would like to invite Ms. Aleksandra Przegalinska, Vice Rector and Associate Professor at Kosminski University, to start her presentation and to tell us more about the artificial intelligence, exciting opportunities and challenges ahead of us.
Hello, everyone. Hope you can hear and see me well. Andrea, would you confirm with me whether I am heard and everything is fine?
Yes, I can confirm that everything is well.
Okay, perfect. Hi and welcome. It's fantastic that so many young people, high school students are interested in artificial intelligence. For me, it's a good morning. For you, it's a good afternoon, since I'm talking to you from Massachusetts, so I'm quite far away, but nonetheless, I'm extremely happy to be here, and thank you for the invitation. I will now share my presentation so that you can see what I have prepared for you today. So hopefully that's sort of visible already, and let's make it a full screen. I hope that works. And if it does, then let's move on. Okay, so opportunities and all the exciting stuff related to artificial intelligence, but also some challenges is something I would like to address. And obviously, in many ways, also follow up on what the things that have been just said, because I think, we've just touched upon how complex and, problematic in some cases AI can be, but on the other hand, how many benefits it can also bring for us. So I myself, I'm, as Andrea just introduced me, Vice Rector of Kosminski University, which is a business school, but I teach AI at that school. I teach AI to business students. I've worked with MIT. I'm currently at the American Institute for Economic Research, and here I'm researching the topic of artificial intelligence and the future of work, right? So that's something that we've also just touched upon. I recently wrote a book, Collaborative Society, with my colleague on the topic of collaboration that is mediated through technology, but also on how technologies will impact the job market in the future. And actually, I think, let's say my way of looking at it is quite promising and optimistic, in the sense that I do believe that artificial intelligence can become this assistive technology that can really make our work more efficient, but also more satisfying in many different ways. And this is something I address, and this is something I also currently research here in Massachusetts. So I will briefly touch upon that matter as well later on in this presentation. So interestingly enough, maybe I'll just add, some of these things are written in Polish, so you cannot probably read it, but by training, I'm a philosopher, and I'm self-taught in programming. I just started being super interested in the topic of artificial intelligence before starting to write my PhD. And I was really, obviously, in some level, I would say, obsessed with the Turing test, right? So the possibility of a machine to fool human into thinking that it's also a human, in the sense that it talks so well that it's very hard for you to distinguish, whether you're talking to a human or to a machine. And this is something I devoted my dissertation to. And I started writing bots at that time, so little pieces of software that can communicate and talk to humans. And that was a very exciting journey that I embarked on, and I continue today. So but now to AI itself, the main topic of our discussions today. Obviously, I guess one of the reasons why we are all here is because artificial intelligence is booming, right? And for the past couple of years, we've seen how it became like a really mainstream topic, but also how it became something that is really applied, right? Not something that we just talk about. We talk about AI, we can watch movies about artificial intelligence, Terminator, Ex Machina, a Black Mirror, whatnot. But on the other hand, what is happening these days, because we have big computational power, we have a lot of data, and we have also different algorithms that allow us to work with that data in an efficient way. We have AI that is really scalable and scaled across different organizations and sectors. We have it in logistics, we have it in the medical sector, we have it in education, in legal sector, in finance, even in agriculture. You can find AI almost anywhere. So that's definitely a dramatic change, because artificial intelligence has been with us for quite a while already, but it was more of a, let's say, cryptic field of research. Military was interested in it to a large extent for many decades now, but the mainstream sort of, or mainstreaming of artificial intelligence is a new phenomenon. And you can say also that artificial intelligence is this general purpose technology. What does that mean? Well, you can compare it to steam engine, or you can compare it to the internet. So those technologies that really make a big disruption, right? And can be applied in so many different ways to solve problems. So that's definitely something that is happening, and it's very exciting. Now, obviously, AI is also this very big discipline, right? It's a whole umbrella of different things. And if you feel that you would want to try it out and work in the field of AI or study AI in the future, you can definitely choose a sub-discipline for yourself, right? So you can think about becoming an expert in natural language processing, like myself. So I work mainly with text and language. There are many things that you can do. You can make AI process text and, for instance, make AI translate a document for you in a way that will be, let's say, more sophisticated than what we have seen through Google Translate, right? So it will not be like a direct translation from one language to another, but actually the type of translation where you will be able to see the nuances of the language and the context, right? So why is something being said? How is it being said? And how to really utter the meaning of what you're saying in a different language. Natural language processing is also information extraction. You can ask AI to read the book for you and summarize it. And again, like 5 years ago, it was absolutely not possible. But today, it is, right? Today, you can ask AI to summarize something, a piece of text for you in a meaningful way. On top of that, also text-to-speech, speech-to-text solutions. This is very often linked with NLP, right? So all the virtual assistants, chatbots of different kinds that talk to you, are trying to come up with the best possible answer, also using voice. This is yet another discipline that is really booming in terms of artificial intelligence. Another very big field within AI is vision, so seeing. So we've just covered hearing, how AI can hear what people say and try to respond. And now vision, right? Another field of perception. AI is able to recognize images, and you know it, right? Very well, because you have, for instance, smartphones. I'm assuming many of you, and the smartphone would recognize your face, and that's an AI algorithm that allows for that, right? On top of that, AI can also generate images. Unfortunately, this field of AI is mainly explored in deepfakes today, but it's plenty of opportunities. Like there are plenty of opportunities for this field to expand in other domains as well. So you can think about generating art with artificial intelligence, right? And different types of styles. So definitely this is yet another field. We have those networks, they're called GANs. General adversarial networks, and they're very good at image generation, so they can create something for you. And obviously, we also have other types of algorithms, machine learning algorithms that allow for prediction. This is how AI is used mainly in business today, right? If you want to make a prediction, how will the demographics change in a given country? I'm from Poland. I can ask a question to the model. How will the demographics of Poland look like in 2050, right? How many elderly people? How many young people? Give me a few scenarios. And then the model will spit that out. And if I have historical data to feed it with, it's going to tell me how the future may look like, right? So that's yet another very important branch of machine learning. And we have most advanced techniques here, such as deep learning, that are somehow inspired by how our brains are processing information. So that's yet again another very important domain, which is called deep learning. And on top of that, we have also robotics. Robotics hasn't been really developing all that well. I'm sure some of you know great examples of robots such as Roomba, the vacuum cleaner, or Boston Dynamics. So a robot that has AI is different from a classical robot in the sense that it's going to be able to learn somehow and adapt to the situation. Whereas a typical classical robot, which is just automated, is going to repeat the same tasks over time. So that's a thing that we should be able to distinguish somehow. And this field is very, very hard, notoriously hard, right? Because robotics needs to integrate hardware and software work and many different modules, right? And robots confront physical reality. That is very, very hard, right? They can fall, just very often they're not able to omit obstacles that for us are easy to omit. So robotics is this a very interesting field that hasn't been really booming yet, but I'm sure it will start booming very, very soon, right? So in terms of what happens within AI, this is something that is definitely out there. Now, let's have a look at a few trends regarding artificial intelligence and trends that can also impact the development of artificial intelligence in the future. So one thing that was also addressed before is, how AI can be really beneficial to humans in various civilizational challenges that we may have, right? There are systems like this one. This is a Canadian startup, Blue Dot, that are able to send us weak signals of a pandemic that is just about to begin. So they can be early detection and information technologies that would allow us, for instance, to prepare ourselves a bit better for a public healthcare crisis or pandemic like the one we have right now. So that's the predictive component. Many other people are also exploring how artificial intelligence can be, for instance, useful in tackling climate change in the most granular way, right? So we today say, all right, it's great that AI can be applied in business, but since it's a robust general purpose technology, what it should also be able to do is tackle things that we all care about. And this is something we expect from artificial intelligence, and we should be rightfully expecting these things from artificial intelligence. So that's one thing, right? Different types of challenges. Another thing is obviously this whole realm that was just covered, right? So the problems, the ethical problems with, let's say, algorithms and algorithmic management. You can think, that on one hand, AI is great at making decisions, but as was said previously, if it's a black box and you don't know exactly how the decision was made, you're going to have a problem with scaling it, right? So that's something that we will have to address on many levels, right? On one hand, obviously, the European Commission has its own approach, trustworthy AI, and is planning to adopt regulations. On the other hand, researchers have to focus on increasing that transparency so that in the future we know how a decision was made. Here on the slide, you can see this very famous moral machine test that each and every one of you can take, although it's a hard test, I have to say. I mean, emotionally hard, because you're making decisions in circumstances of huge ethical dilemmas for and on behalf of an autonomous car, right? So in that sense, you're going to have to tell the autonomous car whom to prioritize in a situation of dilemma. And this is extremely hard, and it has not been solved yet. It hasn't been solved for decades and centuries for us. And for autonomous vehicles, then the problem presents itself in a new way, because it's no longer that the humans are making a decision, right or wrong, and take the responsibility for it. It's that the AI takes the decision and therefore should be held responsible. But in what way? We don't know yet, right? So this field of ethics and AI will be definitely something we will be exploring in the coming years. Now, on top of that, we may have some interesting revolutions, technological revolutions coming up. One example of such technological revolution would be the quantum computer that is yet to arrive. We don't have them yet. Many technological giants are working on quantum infrastructures. And obviously, also, I know that the European Union is tackling this topic as well in various debates and initiatives. And so these quantum computers will be able to process data in a way more efficient manner than the systems that we have today, right? So the speed of data processing will be incredible. The algorithms will be, solvable. There will be algorithmic problems that we cannot solve today that will become solvable, probably thanks to this new infrastructure. There will be many challenges related to it as well, in terms of cybersecurity, for instance, but nonetheless, quantum computers plus AI can be a really great boom when they finally arrive. And let me just say that it's also possible that these quantum hardwares will be more ecological, right, more sustainable than the systems that we have today, because their way of processing data will be quicker, and therefore they will just eat up sort of less energy, hopefully. Oh, that's the dream that we at least have. All right, what's next? Many interesting, I would say, collisions or intersections between artificial intelligence and other domains that we have to look into. I don't know if you know this project. These are xenobots. So skin and heart cells of an African frog that were first, just sort of designed as a simulation, by an artificial intelligence system that said, okay, this is the way to kind of combine these cells together and let's see what comes out. And then these systems were printed. And these are, in fact, something you could call artificial life, because it's a combination of biology and artificial intelligence, right? And what will come out of it, we also don't know. We just know early examples that such systems can be built, right? So AI is the designer and AI prints them out, but in fact, they are in some way alive, right? They don't have metabolism and obviously they don't reproduce, but they do move, right? So this is like an early, let's say, scent of life that we can see here. So what to do with this whole field of artificial life is something that is also today a great, I would say, question mark. And let me move on to my discipline, because I wanted to show you just a few things in terms of what we're doing and also what happens in natural language processing. I think language processing will become this very, very important domain in AI. It already is, but I think it's going to be even more influential in the coming future. Why? Well, because we have plenty of text. We have plenty of text, unstructured text online. We produce text on a daily basis, and systems that can efficiently process text that we produce in social media and elsewhere are those that will probably be very, very important also for business, right? And this is the whole realm of conversational AI, for instance, and also AI that mines text and can summarize it. So something we've mentioned before. So we have plenty going on here. Also in regards to, for instance, virtual assistants, we currently can have virtual assistants that are generated by artificial intelligence. So the image of a person is generated. These are not real people, right? They are sort of recreated from images of people that AI has seen and has made an ensemble out of it and created those virtual assistants. But they also possess the capacity to talk to you, to speak, to have a conversation, right? So it's a bundle of different algorithms that is hard to distinguish from humans already today, I think, at least for some of us. And in the future, we will have similar types of simulations. This is a project called Soul Machines. And I don't know if many of you immediately recognize that the person you see on the screen is actually not a real human person, but artificially generated persona, right? So here it's just obviously, a short movie, but in reality, this persona can be responsive to your voice, to your gaze, right? And also express some mimics. So there will be quite a lot going on in this area. Now, okay, more so, we have very interesting examples of systems that can talk to humans in a way that is not trivial today, right? So, for instance, systems such as Project Debater, quite interesting, that engages in various debates with humans on hard topics. Can be taxation, can be higher education, can be human rights. And if you present it with very complex and sophisticated arguments, it's going to reply to them. So the system is not just, a Q&A little chatbot, but rather a storyteller, really, that is able to kind of make a comprehensive statement about something, including many different arguments. And that's a change we have seen, right? Those NLP systems are no longer trivial. They can be taken sort of to the next level. And also, maybe you have heard of GPT-2 and GPT-3. These are the so-called transformers, so new types of text generators that allow for predictions. So what they do is they come up for instance, with the best possible ending for a sentence that you have started. So let's say you start a sentence and the system is trying to figure out what is the most sound way in which this sentence could finish, right? So they kind of work in reliance with the pragmatics of the language, and they can do many more other things. So they can, for instance, before we move further, I'll just say, they can also, for instance, make music. They can generate music. They can generate stories and narrative. They can generate poems. They can generate various works of art, right? Even image. And on the other hand, they can also code. So you can tell them, listen, code this and that for me, I need to search this database, and the system will do that for you in a formal language, right? So that's also a big change that we today perhaps can say in a cautious manner, that coding per se, the meticulous work of coding, will not be our job. It's good to know coding. It's great to know programming, to understand how these systems kind of perform and how they work. But on the other hand, you will be the architect of the whole system and the designer, but the meticulous coding doesn't have to be on your side, because the system like this one, like this transformer, can do that for you, right? So there's definitely plenty going on. And let me just mention one more example, how AI can become more specialized. This is a nice project, I believe, by Google. It's called Mina, a very beta version at this point, but it talks using only urban slang, right? And uses emoticons. So it speaks to young people as a young person, right? And AI can be trained today to become this kind of companion, sort of, that uses the same language that younger generations, Gen Z, like yourselves, millennials, are using, right? So that's also quite interesting stuff happening. And now let me just briefly touch upon our research. I know that I don't have plenty of time left, but let me just try to be very brief about it and to show you a bit about what we're doing. So we are a team of scientists spreading between Poland and the US, and we also collaborate with various other scientists globally. And we're very interested in the future of NLP conversational systems, right? And what we do is we're trying to see what limits them from really performing well when they talk to you. Because in all honesty, I think it has happened to you. It has definitely happened to me. When there is a bot picking up the phone at the call center, sometimes I'm just frustrated that it doesn't really, talk to me like a human being, doesn't understand what I'm saying, makes me repeat everything again and again, and makes all those failures that a human would not make, right? So we're trying to tackle the issue of what impacts the poor performance of such systems and how to improve them. And we're using various types of methods. Obviously, we're using various AI algorithms, text mining, sentiment analysis, and whatnot. But we're also, for instance, using physiological signal. So, for instance, to find out whether you're comfortable talking to a robot or chatbot, for instance, that looks like a human or uses voice, we would try to attach these electrodes to see, what kind of signal gets released, right? In terms of your heart response, in terms of your skin temperature, a galvanic response, so sweating and other things, to really figure out, whether you're comfortable talking, interacting to a system like this. And this whole domain of checking, whether the interaction works well, it's called human-machine interaction or human-computer interaction previously. All right. And so what was interesting for us in one of the research was, does it impact, your proneness to have a conversation, whether a system is humanoid or not, right? So you can think about Sophia, but also many other robots that look like humans. And for us, the question is, what kind of response will it generate on your side, right? So how are you going to feel about a system that is kind of tricky in the way that you don't really know whether you're talking to a human or not? Right. And so these are kind of, the readings that we've done. We've actually built a chatbot that looked very similar to this one, right, with a human face, human gaze, and also voice. And we were trying to see whether people would be happier talking to that human-like chatbot, or would they be happier talking to something that is just a simple text-based solution. So here you see the readings, and they look very messy. But when you look at the averages, you can see certain, regularities already, right? So the chatbot with avatar voice is the blue line, right? And your response to it is much more intense, right? Whereas the simple text chatbot, the one that would look pretty much like a conversational messenger, doesn't get that, elevated responses, right? So intense physiological responses in terms of the group that we have, checked, so our study participants. And here is the heart rate, and again, it's much more increased. And here is the facial myography, so frowning and smiling that we can detect here because your muscles are moving, right? And again, the response to the avatar and the, human-like chatbot is much more increased. What does it say, though? Well, when we analyzed the results, actually the result was that people were more stressed to talk to something that looks like this, right? So looks like a human. We're not there yet. We're not ready to talk to systems that are imperfect simulations of humans, because that's very confusing for us. And this is something that, people who will implement such systems, chatbots, various types of systems, robots, have to take into consideration, right? That our response to such systems can vary, and we don't have to like something just because it looks like human. Actually, it can create opposed results. Now, another study we have done that you may also like, that was quite interesting, is the chatbot we've built for the previous work. We've decided to reuse it again to do a kind of analysis that would show us what kind of values does our bot retrieve from conversations with humans. So imagine it's just a tabula rasa, right? So it's just doesn't have any knowledge about the world. The knowledge that it gains is through interactions with all of you, right? With everybody, sort of like it just talks to other people, and through that it finds out about the world. Right? So for us, the question is, what happens to our chatbot? What kind of values does it start to represent once it talks to a significant large group of people? And we've used a system called Tribe Finder. It's also available online, and anybody can test it. It's free, and also it's ethical in the sense that the data is not sold anywhere else, so you can feel safe to use it. It's a system devised by my former supervisor from MIT, Peter Glor. And this Tribe Finder, what it does, here you see my readings of Tribe Finder. I connected Tribe Finder to my Twitter, and it said to me, these are the emotions that you're mostly expressing. This is probably the ideology that you believe in. This is your mental model, and your personality is like that, right? I mean, for instance, you're more of a journalist, which in our words mean that you're a person who asks more questions, and we call politician the type of personality that rather shares their statements than asks questions, right? So, I mean, the system is able to do that, extracting text. And so what was interesting for us, though, in this particular research was, not to see what people or brands think on social media and try to process that, but rather to analyze interactions that our chatbot had with people and to see whether chatbot indeed has any values that stay with it, sort of. And what we found out is that indeed it does. So chatbot is in the middle and 84 other people are around. Some are hard to classify, the blue dots. Some are easier to classify. As you can see, the chatbot is always easy to classify, right? So it does share certain beliefs. It believes that fitness is a great thing. It's more of a person that asks questions than provides answers, which is strange for a chatbot, but that's actually what happened. But more so, and even more interestingly, what we've uncovered was that chatbot changes its mind, right? So whereas humans, when they're once classified in the conversation as someone who believes that environment and nature matters most, right? That's going to stick, right? Across the whole conversation line. Whereas for the chatbot, that's different because the chatbot will migrate and it once will say that, it believes in nature. And on the other hand, it will say, actually, I don't care about nature all that much because these systems are still very vulnerable. They have poor time management. They cannot really refer to what was said before and integrate that. And they very often agree with the user. So whatever the users say, the chatbots kind of very often copies, right? So this is another interesting challenge with these systems, how to create integrity within them and how to support values that we believe are important to foster, human rights and whatnot in these systems so that they don't go in a derailed way and are not biased, right? So this is yet another discovery we have made, and the paper on that is called In Bot We Trust, and it's available so anybody can read it if you feel like it. It's, you'll find it via Google. Now, and last thing that I wanted to very briefly mention to you is that we're researching the world of work, and we don't believe that the future belongs to the idea of replacement of humans. We rather, as a team, would prefer to have systems that help humans at work support them, which will obviously lead to certain reskilling. So we need to have new skills in order to work with these systems efficiently. But then again, what we don't want is a situation in which these systems will be replacing humans and humans will become increasingly unnecessary. So we were very much inspired by this book that I would totally encourage you to read, Superminds, The Surprising Power of People and Computers Thinking Together. That kind of shows that there are many ways in which we can collaborate with technology that will be very fruitful for us. We will get rid of the mundane, routine tasks, but the creative side and the discovery side and interaction side will remain with us, right? So I think it's a nice future, something to really look into. And what we did was, first of all, we did a survey to see whether people are afraid of AI taking their jobs and, working on their behalf in the future. And actually the responses varied, right? So you would have many different people with many different responses, but the majority was not scared. The majority of people who are actually working and knew the meaning of their profession and robustness of their job, right? So that there are many tasks involved and they would still use some help. This is something that they actually appreciated, the possibility to have AI in place. And then we asked also another interesting question: would you prefer your AI to be more human-like and less human-like? And here an interesting, I think, response, particularly for young audiences. The younger people are, the more they are okay to use voice as a channel, and the more they are okay for their AI systems to be more like partners to them and not necessarily just like limited technologies and those like little boxes that are fully controllable. So that's like an interesting thing. And so what we did in the experiment that we later on conducted was we devised tools for marketers according to what they wanted. So we selected a group of 20 people and we asked them, in your work, where would you like AI to supplement you? Where would you like AI to work with you? What kind of relationship would you like to have with this AI? Which platforms would you like to use? And so we gained many different responses, and that's one important thing. AI could and should be personalized according to our needs, right? It would be great if we had the skills to kind of build it, like to not be only just, consumers of technologies, but co-producers. And I do believe in such a future. But what we saw here was that many people had many different ideas about how AI can help them. And then we've conducted experiment. We divided this 20 group of people, right, into two groups. One group worked on their own, alone, and the other group was working with the assistant that they've selected and co-built with us. And guess what? In that task, which was a simulation of a business problem, they had to do some varied tasks and they were standardized the same for everyone. There were marketing tasks. It turned out that we had a 40% increase in terms of productivity on the side of the group that worked with AI. And on top of that, 60% of that group was more happy with the work that they have performed when they were working with AI. So the job that you perform together with technology that suits you and is tailor-made is something that you will enjoy, first of all, and second of all, something that will be done in a quicker and more efficient way, right? And this is, I think, a very nice pathway sort of to follow when you think about how AI can complement our work in the future. All right, and with that, I am done. Thank you so much for paying attention and listening. I will stop sharing my screen right now, and obviously, I'm very open to listen to your questions now or later.
Many thanks for the very interesting presentation. We have some time indeed for a few questions and the rest of them will be discussed afterwards. So I'll go for the most voted questions. How can we be protected from being tracked by artificial intelligence?
Okay, so that's a great question, and thank you for that. I think it's a matter of skills, right? So first of all, well, obviously, you won't always be protected, but a very important skill that I think should be fostered is like really being aware of your circumstances, right? So, I mean, you can, first of all, check the functionalities in terms of your social media, if you use any. So you can check, do they have access to your camera? Do they have access to your data? And if so, in what way, right? So this is a question you can definitely ask yourself. And sometimes you can disable some of these functionalities, right? The other thing, on like a good side, what I would say is that most of the data that is being collected through artificial intelligence is anonymized or pseudonymized. So it rather is something that should support analyzing general trends, right? Rather than just tracking an individual person. Having that said, I'm thinking that probably many of you have had this experience that you talked about something, right? And immediately an advertising of that product that you've just mentioned pops up, right? Everywhere you go follows you, right? That's because very often your microphone is on and various applications want access to your microphone so that they can listen to what you're saying, not only to sell you something, but also to train their neural networks in how people say certain words, because they want them to be able to understand the way people pronounce things, right, in different manners, right? So this is something that you can, again, disable, right? I mean, so there are many things that you can do on an individual level. But on top of that, obviously, there is this institutional level, right? So I think in the EU, we have quite a good privacy protection standards, and really those that many other parts in the world should aspire to, right? So on that level, you can say that you're somewhat protected. But there are regulations that probably will and should be in place, right, to protect us on the level that you as an individual consumer cannot reach. But I think what you can do is really try and have an increased alertness, right, regarding these issues. Really check the functionalities, right? Sometimes, even if it's cumbersome, read what they're saying about, like, various social media platforms, so what they're saying about the, the way they process your data whenever that data is there. So certain awareness, certain digital skills, right, that allow you to really be more in charge of, your own data and whatever it is that you're sharing.
Many thanks for these in-depth explanations. Moving to the next question. What is the most realistic worst-case scenario you can imagine about artificial intelligence?
But realistic.
Realistic.
Okay, I'm going to be very realistic here, since I don't really buy the singularity narration all that much, right? So to me, that's like something to talk about perhaps in hundreds of years from now, or at least 100 years. So I'm not thinking about machines becoming aware in the near future and, getting rid of us and finding us unnecessary and whatnot. But the realistic scenario that I would be afraid of is a situation in which artificial intelligence, for instance, AI-based autonomous weapons, is used against civilians, right? And nobody takes responsibility for that, or those systems become hacked or biased and start attacking people. So definitely, I would say robust, powerful technologies in the hands of a tyrant or in the hands of a despotic ruler. This is something I would be very much afraid of, right? So not AI really going astray, gaining consciousness and will, but rather AI as a very powerful technology that can detect, see people, and can become something that is weaponized, right? This is a scenario that I'm definitely afraid of, and I'm actually one of the people who signed the Future of Life Institute Declaration against autonomous weapons, because this is a realistic thing that could happen to us and that I would like to generally prevent as a situation that would somehow, really, become super challenging for humanity. Yeah.
Many thanks for this. We'll move to the next question.
Can I just say one more thing
Sure.
before we move? I just wanted to say that we have this initiative together also again with the Commission, and we will release next week videos where I was very happy to take part when we talk more about artificial intelligence, also about this ethical component and scenarios for the future. So if you check out, I guess, social media next week, you will see more beautifully produced videos about artificial intelligence with a lot of explanations of these topics, and also some tackling the questions that you are just asking.
That's great indeed. We will make sure that this will be promoted accordingly. Thank you so much.
Great.
Okay, so moving to another question related to ethics as well. If the artificial intelligence did a mistake, for example, a car with artificial intelligence hits someone, who would be held responsible for the mistake that the artificial intelligence did?
Today, the humans, right? So the probably the person who wrote the code, or ostensibly the company that is responsible for the code. However, it is a relevant topic. And, I'd say when you think about autonomous vehicles, today, actually, the debate is more so about connected vehicles that can support you in driving, whereas you still make ultimately the final decisions as a human. and not so much about fully autonomous generation, so fully autonomous or fifth generation, as we call them, vehicles that are just making decisions on their own. Because this is actually a very hard topic. So the question you've asked, right, who is held responsible? Today we can say, well, yeah, I mean, the company, right, is responsible. But tomorrow, actually, when these systems just learn sort of, they have this type of architecture that learns only through experiences, the company cannot be fully responsible for what happens with the car. And actually, many people said maybe it should be some sort of shared responsibility. And some others said, well, if we're not ready to answer this question, maybe we should stick to fourth generation of autonomous vehicles. So in a sense where you are the driver and machine is your co-driver, and still it's a framework in which people are held responsible for their actions, even if those actions are supported by algorithms, right? So it's a very cumbersome and hard question that you've asked. And I think for now we don't have yet the answer, and therefore we're trying to scale technologies that are, well, not making us or not forcing us to really be challenged by this question, and instead are trying to, let's say, support humans in driving rather than making decisions on their own.
Many thanks for this explanation. So we will come back to the questions a bit later. But
Thank
now
you.
we will move with the next speaker. So I would like to invite Mr. Hugues Bersini, Professor of Computer Science at Université Libre de Bruxelles, to start his presentation and to tell us more about the two AIs, conscious and subconscious.
Right, thanks, and good afternoon. And I hope that you can hear me well. I'm going to try to share. I got some problem before sharing my screen, so I hope that this time it will work. So, okay.
Maybe also to activate your camera, because currently we can't see you.
So normally you should see me. And okay, let me share my screen. Okay, can you see? You can see me in my screen.
We can see the way you shared the content, but not the presentation. So maybe you can try with the presentation itself. Yeah, exactly. I think now it's better. Yeah.
You can see the presentation?
Yes, we can see the presentation now.
All right, so let me ask that. Okay, so, right, the title of my presentation is, in fact, trying to understand what's going on in the field. I'm working in this field for nearly 40 years now. And it's interesting to first know that it's a very old field. It's nothing new. AI is as old as computer science. Indeed, the first conference of AI took place in the 50s, so it's a 60 years old field. So why is it turned to be so popular these days? And I guess the answer I'm going to give you is one of the reasons is because we are attending a key bifurcation between two kinds of AIs. What I usually call the conscious AI and the subconscious AI. And let me tell you that they have always existed, those two AIs, since the first conference in AI, those two type of AI was existing. But today, this second type of AI, what I'm going to describe as being the subconscious AI, is taking more and more importance, taking to some extent the leadership, and is trying to substitute with what was done in AI before. So I'm not going to spend too much time. This is just a slide showing you some of the, the important realization of AI, which has been well diffused in the news. And you see that it's a long history. And AI is trying to not only deal with the most rational type of intelligence. That was indeed the case back in the 50s, but we're now trying with AI to cover. This is a slide taken from psychology, not from computer science. But human being is characterized by a lot of different type of intelligence. And AI is trying to cover them all, it's trying to substitute human being in those different intelligence. So not only the rational one, but also the, the body one, also the relational one, what is usually called the emotional one, the linguistic one, the creativity, the musical one, etc. So, but why is AI turned to be so popular these days? Once you know that it's such an old field, and I think that perhaps one of the key reasons is the GAFA, just the GAFA, because they present themselves as being AI companies, and when you realize the importance that those 4 and even 5, and if you also take the Chinese counterpart, even more than that, when you realize the importance that those companies has taken, and because they sell themselves as being AI companies. This is certainly just marketing things, but just certainly one big part of the story. But the second is anytime AI is doing a great achievement, but not only a great achievement, but is doing better than the human for some task, then this boosts AI. And the last task that AI has been very good at performing, that was resisting for a while, was, picture recognition. There is a famous picture recognition challenge, which is we have a picture like you can see on the right of my slide, and you try to differentiate between cat and dog on a picture. And before, in the starting of the 2000 here, somewhere here, the human was doing much better than machine recognition, picture recognition. But what happened is that just 5, 6, 7 years ago, and you can see at the bottom of my slide, you can see this red line here, and you see that we had to wait 2015 for the machine recognition, the neural network, this deep neural network, to exceed human performance. And this made a very incredible, important difference, because imagine that you're doing 1% less well than a human being. No one cares, because you wouldn't trust, for instance, a cancer diagnosis to a machine which is performing 1% less in the quality of diagnosis. But at the moment where you can do 1% better than the human being, even if it's just 2% difference, this make a huge impact, because now you would much more entrust a machine recognition than human being in order to, for instance, diagnose a cancer. And this is exactly what happened just 5, 6 years ago, where from the 50s, I remember reading a book where Marvin Minsky, one of the fathers of AI, was being asked, how could you make machine being able to perceive, to make visual recognition? And Marvin Minsky thought that this could be a very easy task, because for us, it's so easy to recognize a cat from a dog. But he was imagining that it could be so easy for, software. So easy that he was even given that to one of his students, a kind of memoir type of work, something that you can do in 5 or 6 months. We were back in the 50s, even the 60s, but yet we had to wait 60 years in order to make better than human for image recognition. So no, I think perhaps the less marketing-based reason why AI is becoming so popular, even if it's such an old field, is because we in fact are attaining a kind of bifurcation between two AIs. And in order for you to understand better how I can differentiate those two AIs, I'm going to give you rapidly 4 examples of that. The first one is the society game, the board game, the famous game AI is playing, like chess or like checker, or like, more recently the Go. And, well, if you think about tic-tac-toe, which is a much easier one to play, and I know that you all know it, and since then, because I don't have to explain it, you have really 2 ways to play tic-tac-toe for a machine, for software. One is, you let the machine play and compile the statistics of the winning game and the losing game. So you have the AI that just learns and performs. So there is no reasoning, no intelligence. AI just plays and just memorize the games that AI wants and the games that AI loses. And just by kind of statistical compilation, AI can deduce, that, for instance, if AI has to play the cross, putting the cross in the middle would definitely lead the software to much likely win than putting the cross everywhere else. This is not how I teach my students for more than 50 years now to play and to implement AI. There is a famous algorithm due to John Van Neumann, one of the other fathers of AI, to play tic-tac-toe, which is called, the min-max algorithm. The min-max algorithm is interesting because in order for, I'm not going to describe it to you, but what is interesting is that in order to play min-max for software, you have to try different moves, then see the move of your opponents. What is really key for the min-max is at the end of a succession of moves, you have to put some heuristics here. And that heuristics is put by a human expert who knows the game and who can deduce how likely we are to win when we reach this configuration. So to some extent, you need some human expertise in order for the AI software to win, because this is put by the human. And what happens is that the human is guiding the AI. The AI needs the human to accelerate, and which is in the case of tic-tac-toe, you could go until the end. But remember the chess, because of the chess is so, exponentially exploding, you cannot reach the end of a game. So you had to stop somewhere, and in fact, the best player implement this kind of min-max, and they stopped after 6 moves, for instance. And 6 moves is already a lot of branches, and you have to put some heuristics here, some numbers for, providing and helping the software to find its way. This is definitely not how AlphaGo has won, because AlphaGo has won exactly in the same way that the tic-tac-toe before, playing randomly. AlphaGo won the game, not implementing min-max, but just playing randomly and memorizing the winning games, in contrast with the losing games. And by doing so, what is wonderful with AlphaGo, AlphaGo learned to play by just random moves, but it was such surprising that not only the best Go player lost the game, but he couldn't understand how he lost it, because you can see that on YouTube. It's pretty impressive. There is a certain move which is now being called not the Go move, but the God move. It was such a surprising move. Lee Sedol here, the champion of Go, was totally, completely destabilized by this move. In fact, this move never been played by any human before. That was a completely new way of playing. AI is becoming so powerful by random playing that AI could explore an incredible world of new way of playing Go that has never been explored before by human. So AI beat it, Lee Sedol, because AI discovered new way of playing Go that human was never played before. Remember that when human put heuristics and when human put numbers, it has to play in the human way, while AI just discovered. And this kind of worried, because to some, because when you are facing a very complex situation and you let AI with its power these days, with incredible power of computers, they can discover way of resolving the situation that has never been proposed before by a human. And not only that, but they really push you out of the loop. They ask you, don't help us. We don't need your help. Don't try to guide us, because by trying to guiding us, you put ourselves in a kind of local minima. We're doing better without you. And another famous example is a self-driving car. You could imagine basically when an engineer is trying to control a process, not a process as complex as a car, but suppose a much easier process. This is the kind of thing that you're being taught in university. You see those differential equations. I don't need to explain that to you. It's not necessary, but you have differential equations that are trying to describe the process. Then you write the objective that your process is trying to achieve, and you try to find the optimal control. This is totally not applicable for self-driving car, because self-driving car are so complex that you can even not model that by numerical equations. So another way of doing so, and in fact I did my PhD in the 80s on self-driving car, and I was using neural network. That at the time it was not being called deep learning, whatever. It was just simply called neural network, but it's exactly the same thing. The way we did it was just by imitating human driver. We was not trying to make mathematics. We're just trying to imitate human drivers. How we did that? We're just recording human driving. So we were recording everything the human drivers was perceiving here, and we were recording everything the human drivers were doing. That was on a highway in the United States, so it's much easier to drive in a highway in the United States than in a small road in Italy, for instance. But anyway, that worked quite well. And the neural network was, able to learn to imitate the human drivers, putting in the input everything the human drivers was perceiving, and putting in the output everything the human drivers was doing. So you had a kind of sensory motor processing being captured in the neural networks. Another example that we heard a little bit in the previous talk is the translation. Here it's a stupid French sentence that I put in Google Translate. It's a double meaning French sentence. If you don't understand French, it doesn't make any it's not important, but it's kind of a humorous, spiritual sentence. When I was learning AI and natural language processing back in time, I remember that in order to translate a sentence, you had to do a lot of intermediary processor. And you need this human in order to code those intermediary processing. Like, for instance, a syntactic analysis of a sentence for you. You try to find the verbs, you try to find the adjectives, the names, etc. Then you try to deduce the meaning of the sentence, And you do that, subsequently, you do it step by step. And this is not at all how Google Translate works these days, In fact, this is a translation proposed by Google. It has lost totally the meaning of a sentence, at least the humor of a sentence, even if it's kind of faithful translation. The way Google do it is by deep learning again and big data. Google is teaching a huge neural networks, to associate to French sentences, English sentences, and that is the reason why you can put here any language and find here any language. And implicitly, what is interesting is that implicitly in the neural network that Google is, using, there is somewhere hidden syntactic analysis and a semantic analysis. But it's the reason why I call it subconscious. You don't have to explicitate the syntactic and the semantic analysis. Google and neural network will just, find it, learn it by just processing the translation that have been proposed by human being a long time before. And the last example is, this famous possibility of using AI algorithms to, replace justice or replace lawyers. There was an old dream in AI. In fact, I remember back in the 80s, there was proposal of AI software for, helping lawyers to take decisions. And that was based on case-based reasoning. But again, what you had to do is to explicitate any type of situation. Here, it's not exactly justice, but I remember a word by a famous linguist called Schank, which were trying to, do natural language processing. But for instance, if you want to understand what happened in a restaurant, you can, simulate everything happening in a restaurant by explicitating, the actors of a restaurant, the different stages taking place in the restaurant, and you need to explicitate all those things. Now, there are people dreaming that a neural network can do it by itself. Again, you would put the case in the input here, and the output of a neural network will be able to tell you if the guy that you put in the input is guilty or innocent. So in order really for you to understand how I like to differentiate those two AIs, so the AIs of before, the AIs of the 80s was conscious, in the sense that there is a lot of problem decomposition. And why did you need to decompose the problem? Is because you needed the human help. You try to decompose the problem in order to reduce the complexity of a situation. And because you have this complexity reduction, you needed human expertise, and then you would explicit and exploit human expertise. And then instead of just relying on brute force, you remember that in the 80s, we didn't have this brute force that computers have these days. We didn't have these billions of data that the first speaker was referring. We had few data and we had a small amount of computer power. So we were still relying on brute force. Anything a computer is doing is relying on brute force, but we needed a lot of human guidance to concentrate this brute force only on the places that human couldn't do. This has disappeared these days, and this unconscious AI rely a lot on big data, machine learning, parallel processing, blinded brute force. You see there's a big difference between a kind of white brute force and a black brute force. This brute force is fully blinded, like I was mentioning when I was speaking about Go. It's totally indifferent to human expertise. It's fully black box, and as you know, this is a key issue that we might discuss later during the QA session, because could we support, could we accept that? For instance, let's again refer to the Go. For me, it's not a progress in Go when a human is being defeated by a software, but it's even a regression because Lee Sedon couldn't understand how he was defeated. So to some extent, he has to relearn to play Go, because not only was defeated, even being the best Go player, but he was defeated by an understandable way of playing. So, and who is responsible for that? Who is responsible for those bifurcation? But if you go back to the history of AI, I guess that one key responsible was, Alan Turing, who invented, this idea of what should an AI system be. You remember this famous dialogue: an AI would perform well once it is able to confuse a human being on its real nature. If you get the feeling that you speak with a human being while you speak with a machine, then the machine could be qualified as being intelligent. But what Alan Turing wouldn't be able to imagine back in time, back in the 40s and in the 50s, is that one way of doing it is to compile all the dialogues that you could imagine on, on social networks. And just by compiling those dialogues, you do some kind of statistics. And whenever you raise some question, then by statistically find the most likely answers, without understanding anything about what you're talking about, then you're able to propose an answer. Alan Turing would never thought that AI could work this way, because according to him, AI should not only should perform intelligently, but it should behave intelligently, should behave a little bit like a human being. Proposing the right answer for Alan Turing was absolutely necessary to understand what you were talking about. So indeed, this, the first speaker of the afternoon was just making an equivalence between AI and deep learning. For me, it's pretty rough, because when you play with AI for so many times, you know that deep learning is really nothing new under the sun, because a neural network has existed for so many years. But I agree with them that this deep learning is becoming so popular these days, and in fact, gradually, is taking more and more importance, to the point that even some key researchers in AI believe that the conscious AI, the old-fashioned AI, has to fully disappear to give rise to deep learning and big data. And everything could be reinvented by deep learning and big data. I fully disagree on that standpoint, but I must admit that this is becoming very popular these last years. And this indeed what makes possible to differentiate a cat from a dog. And one of the reasons why deep learning has turned out to be so powerful and so popular is because before deep learning, people were still using neural network. In fact, neural network was being used even in the 50s and the 60s, but people had to help neural network to perform well. So they were doing feature extraction. And this, the great achievement of deep learning is because we have so many data and because we can use so powerful computers, that this preliminary feature extraction done by human expertise is not needed any longer. And as I was telling, it's interesting to see that those two AI have always existed since the 50s. And in fact, just to let you know, this is slides that has been taken out of the first AI conference. And you had someone called Arthur Samuel who was using a reinforcement learning to play chess, exactly like AlphaGo is using reinforcement learning to play Go. So we were just back 60 years before. And this is Frank Rosenblatt. We're explaining what is a neural network with this input layer, the output layer, and even the hidden layer was existing in the neural network back in the 50s. And for me, the good AI is a little bit what happened with Watson, which is, according to me, one of the most powerful AI systems these days. Watson has been inspired by this famous, software being able to defeat, again, in a TV game called Jeopardy, was able to defeat best human players. And Watson is being used by oncologists for diagnosing cancer. And what is interesting is Watson is a toolbox of AI. You have many, many, many types of AI inside. You have some bit of learning, so it's not that learning is not useful. You need a little bit of learning. You have a lot of natural language processing. You have a lot of uncertain processing. You have a lot of rule-based. So the old-fashioned AI is still there. So I guess that this is the right future of AI, is to use this mix, and you need to have those different competencies, a bit of natural language processing, a bit of learning, a bit of uncertain processing, a bit of statistics, and a bit of everything within this Watson, for instance. And I'm reaching my conclusion. What is interesting with this 2 AI is that it's not really new if you're interested in cognitive psychology, because a very famous researcher in cognitive psychology who even won the Nobel Prize in Economy, Danny Kahneman, in a very interesting book called Thinking Fast and Slow, helped to differentiate 2 types of cognitive processes, not in machine, but in humans, and he usually call it the system 1 and system 2. But as you can see in this slide, you could call it unconscious and conscious. And this is the reason why I'm using this difference between unconscious AI and conscious AI, because to some extent, it reflects this differentiation we have in our own mind between conscious and unconscious processing. And as you can see, the unconscious one is automatic, easy to process, everyday decision, error prone, and the system 2 is slow, effortful, etc. But what is paradoxical these days is that the more a situation becomes complex and novel, what normally force human to, rely to consciousness. For instance, if you are interested in philosophy and psychology, you will read that you have to be conscious once a situation is new, original, never met before. Then you have to process and be, to some extent, more intelligent and try to understand how is it possible, and then you have to process it consciously, etc. What happened with machine is, to some extent, the other way around. These days, when a situation becomes more complex, like a little bit what happened with AlphaGo with respect to chess, what happened with driving a car with respect to driving a simple process, paradoxically, once the situation becomes more complex for machine, you have to create and raise much more unconsciousness in machine than in human. So it's just the other way around. Machine has to become unconscious in order to deal with a complex and novel process, while for human you need to be more conscious. And this is my real life slide. We were speaking about machine becoming much more unconscious, and we raised already that issue before in the previous talk and in the QA session. But I guess that this, the evolution of AI to build more and more black box, complex and unconscious system is really a very frightening issue if you think that in general, responsibility should go with accountability. And we definitely need to be able to open this unconscious huge and black box more and more if we entrust, a machine with such responsibility of, in fact, the previous speaker mentioned, autonomous weapon. And in fact, this is one of the most frightening evolution of AI. AI is able to kill these days. AI is able to, build a very powerful weapon. And for those weapons to act, to some extent we can accept that, but we definitely need to understand why and how those type of systems decide. I think I'm going to stop here. Thanks for attending.
Many thanks for the interesting presentation. We'll now move to the question and answers part. And I would like to ask you, if possible, we have this question here. Can you tell a bit more about the basic algorithms underlying artificial intelligence?
Well, indeed, there's been a lot in AI. AI, as I was telling, is a huge blue box. For instance, when you use Waze, in order to go from point A to point B, you don't use any kind of learning. You just use a graph-based search. So you use an algorithm, which is a very popular algorithm called A star, which is a search type of algorithm. So back in the 80s. You remember the time where AI built expert system, rule-based system, and I think those systems are still very interesting, they're still powerful, and I think students should learn those systems. So there is a huge amount of algorithms back in the 80s that are still very important to learn. And more recently, in fact, we were discussing the evolution of AI towards what I usually call the subconscious AI, so the machine learning based of AI, and you have to follow that even. You have to learn statistics, you have to learn, machine learning, reinforcement learning, a bit of neural networks. So there's a bunch of algorithms underlying AI. You have to learn a little bit of natural language processing too. So there's not one algorithm. There is a box of different type of algorithms that need to be all of them learned, because I think that, as I was telling before, the most interesting AI system that will appear in the future is a mix of a lot of different things.
Many thanks for this. Moving to the next question, what would you say are common misconceptions about artificial intelligence?
Oh, yeah. So I'm a little bit like what was saying before. I think that there is a lot of mystification of AI. There's one interesting, when you have a software that is able to recognize a picture. So I show the slide, but I didn't spend time on the slide. You have today Google, which is able to produce, systems that are able to recognize what happened on an image. So, for instance, you have an image, and the Google will tell you, or the software used by Google will tell you, on this image, you have, I don't know, a man wearing a black shirt and playing a guitar, or you have a dog running into the sea. Whenever you do this task for yourself, you understand what is a man playing guitar, or what is a man wearing a black suit, what is a dog, what makes a dog running, etc. You understand those things. You have to understand that when a software is able to do exactly the same thing as you, so in terms of output, is able to do as well as you, but software don't understand a key word of what it's talking about. So when a software tells you, on this image, you have a dog, or on this image, you have a man playing a guitar, software does not understand what is a man, what doesn't understand what is a dog. So don't be mystified by what AI can do these days. Even when an AI system is able to make fake news or creating a music, it's just treating data. It's not like the human who did the music before. I remember having a software able to create a Beatles song. It's very popular. You can go on YouTube and you can hear a Beatles song called Daddy's Car. It sounds like a Beatles, but it's nothing like a Beatles. A software never will have the creativity of the Beatles. Don't be mystified when you see the output. Try to understand how it has been processed and how it has been obtained.
Many thanks for this. We'll move to the next question. What jobs are most at risk to being replaced by artificial intelligence?
Well, I think this has been well covered by the first speaker when he was telling that, the most repetitive job, to some extent, the job which looks like an algorithm. Going from step A to step B. I think this is definitely the job that will be really easily replaced. But there's a huge amount of job, the job that needs, for instance, social skills, body skills, different kind of intelligence, and the mix of those different type of intelligence. For instance, let's take, for instance, medicine. I can easily imagine that radiologists might be a little bit threatened by neural network these days, because in order to diagnose a tumor on a radio, on a picture, I really believe that machine is doing better than radiologists these days. But no, think about a dentist. And when you see, when you go to the dentist and you see these many skills that the dentist must have in order to cure your teeth or to cure your mouth, you realize that the dentist must have empathy, must have body skills, must obviously have a rational and IQ, need to understand what you're suffering from. And all this mix of skills will definitely escape AI, and I guess for very long.
Many thanks for this. We'll open the floor also for the other speakers, as we have some time for a question and answer session. So when artificial intelligence will be much more developed and will not rely only on refining data, will it be possible to hold AI accountable, for example, discrimination? I'd like to invite the speakers to reply to this question. Maybe Martin, if you would have something to add.
Well, I mean, I don't think AI in itself will be responsible. There's somebody who's responsible for AI. So whenever you have a system which does not fulfill legal requirements, for example, in terms of non-discrimination or whatever, also in terms of environmental law or anything else, somebody is responsible for the system, and therefore that's the person who's in the end responsible for the breaking of the law if such a thing happens. So the idea that there is software which would be responsible and therefore which you would want to punish, I don't know, by removing it from the server, that is not very reasonable. Obviously, you would take measures in order to, that the responsible would have to take the appropriate measures to make sure that the software does not continue to break the law.
Many thanks. I'm just checking if Alexandra will have something to add on this.
Well, what I would just say is that perhaps a little thing we have not covered before was related to the fact that obviously this discipline is constantly progressing. We've had, different types of algorithms that prove to be effective, deep learning algorithms to tackle various issues. And probably we will be moving forward beyond deep learning as we know it today, right? So many people talk about further inspirations that the human brain, for instance, could propose sort of, or we could see various inspirations through how the human brain kind of works when we find out more about it. And probably this will also change the networks and the way they work, which will not make them really conscious. And to me, that's a sort of condition that predetermines any kind of responsibility or liability, right? So I think, Professor Belsini has really tackled that really well. And he said, we will have more context-aware systems. By context awareness, we mean like that various types of sources of data will be aggregated together, and the system will kind of have more sources of information to complement whatever it needs to do. But that won't mean that it will be able to really, understand whatever is happening and the task and the goal behind the task the way we see it, right? It will be better at it, probably, right? It will do it even better than it does today, like conversation with humans, right? This conversation can be as smooth as possible, but it will not make the system kind of understand language in the way we understand it, in a fully embodied contextual way, right? With meanings, with semantics and whatnot. So, I do see how AI will be progressing, and I do see that there will be many questions that we will be asking, probably to the companies, maybe some sort of, new forms of liabilities, responsibilities will have to be kind of put in place in order to answer, but probably not AI itself, not anytime soon. So, and my understanding is that, the definition of responsibility for such a system will change. Maybe there will be some sort of systemic responsibility for systems that learn from humans, from various sources of data, sensors and whatnot. However, I don't think that AI per se can be held responsible because, what would be the way to punish it, really? Or, how would we want to execute that is, I guess the main question here. So I don't see that anytime soon.
Many thanks for your intervention. Just checking if Professor Hugo Bersini would have also something to add on this.
No, I tend to agree with what I've been said before. I think, in fact, I don't see a machine or software being any time responsible. I guess that what's going to happen with software is a little bit what is happening in the medical world these days, because medicine is becoming so complex and there's so many actors being involved. Less and less doctors are being guilty when there is a problem, with the patient. You can sometimes identify a singular responsibility, but it's becoming harder and harder. So what happens is that you pay insurance and you be compensated for the damage that you've been through, And I guess that this is going to happen with AI. I'm pretty sure that, for instance, if you imagine in the future self-driving car, they will have some accidents. Statistically, there will be much less than the human driving accidents. But it will be so hard to identify the responsibility of the software because anyone who is working in AI these days, to some extent, take part in the running of those software these days. Any progress in machine learning, any publication, to some extent, would be responsible for what happened in this software these days. So it's becoming very hard to identify a single responsibility. So what's going to happen is a way to compensate for the victim instead of pursuing or training a software or a robot.
Thank you so much for your interventions. Moving to the next question. Do you think that the current landscape of artificial intelligence industry is beneficial to our economy? So maybe Martin, if you'd like to start on this.
That's a very difficult question. How would you answer that question? Whether the current landscape is beneficial to our industry, it is certainly more beneficial than if there wasn't any AI. So in that sense, the AI industry is beneficial to us. But it certainly would be more beneficial to us if there was more AI developed in Europe. And so in that case, it's not beneficial to us. I think Europe certainly has a certain gap towards the United States and increasingly also towards China in AI, which is partly based on the fact that much of AI, well, as I said earlier, AI is very much dependent on very large databases. The places where you've got the largest databases right now are the big platforms. So the Google, Facebook, Alibaba, Tencent. And since Europe isn't present in the big platforms, it doesn't really have access to this huge data sets which have been so far used for the AI development, with the result that AI companies and the AI development has really taken to a large extent place outside Europe. And clearly would be beneficial for Europe if more of that was taking place within Europe. And that is to a certain extent also what we're trying at the European Commission, trying to incentivize more development in Europe, increase investment, get better collaboration, create the conditions necessary for AI to be also not just used, but also developed in Europe.
Thank you so much. Would someone else would like to add something on this? If not, we will.
I mean, I'm happy to just really, in a way, echo and say that, of course, it is beneficial. We've seen benefits in healthcare, for instance, when we talk about diagnostical tools, therapies, search for therapies that is facilitated by artificial intelligence. When you think about, major developments in logistics, transportation, with the usage of various machine learning algorithms, you see many benefits already now. However, when you compare, obviously, with players such as the US or China, it's a slightly different ecosystem. I'd say that Europe is in the peloton, but it's closing the peloton. So we'll see perhaps some regulations regarding open data pools will facilitate that in the coming future, because definitely it can be more beneficial than it is today. But yeah, I mean, we definitely see major benefits, and we've seen them over the past few years.
Thank you so much for clarifications. Moving to the next question. AI and machine learning in the domain of linguistics, for example, tends to be trained on Western models more. How can we make sure that artificial intelligence remains unbiased? If there's someone who would like to start, yeah, please go ahead.
Yeah, I can say something, because this whole bias thing is pretty confusing. Whenever I heard about the bias, in any, obviously, natural language processing, but also in discriminating. There's been this famous Compass software that was, deciding about liberating, freeing a prisoner, and trying to predict how likely it was to, start again, things like that, or discriminating women from men in the access, etc., etc. So it's a pretty confusing issue, because an algorithm is not biased. It doesn't make a lot of sense to accuse an algorithm of being biased. Data can be biased to some extent, and an algorithm, for instance, the machine learning. Well, obviously, there's two kinds of algorithms. This is the conscious one, where a human programmer is building them. And everything inside should be understood. So we can obviously, and I'm defending the idea that algorithms should be open, accessible, which is definitely not what's happening, for instance, in the GAFA world. I'm defending, this type of GitHub way of building algorithms. So once you have the algorithm open, once you have the algorithms, inclusive, and once you accept some form of participation in the writing of the code, like we have in GitHub, then you less and less, are surprised or disappointed or shocked by what an algorithm is being producing, because you understand how it works. Obviously, this is less and less the case when the algorithms are becoming more and more complex and opaque, and you don't know how they run. And this is a lot what happened in the GAFA world with our data, etc. But even in that case, I mean, what is, if you take a simple machine learning algorithms, in general, they just try to automatize decision that is implicit in the data. So the data are biased, but not the algorithm, because the algorithm is just, extracting an automation of what there was in the data. So if this Compass algorithms is less likely to give a chance to a black man than a white man, is just because statistically the black men behave in such a way that, and then we have to, obviously, we have to fight against that. But so for instance, you can fight against that, saying that once the algorithm has taken this decision, we should really understand statistically what was the basis of his decision and how we can face that. Because what can happen is that an algorithm, if we rely more and more on an algorithm will amplify the situation that were already implicit in the data. This has been nicely described in a book where I think the title of the book was Amplifying Inequality, because if you have inequality in the data, like gender inequality or race inequality in the data, and if you rely more and more on the algorithm for taking the decision, you will just re-amplify this inequality, because you will just redo exactly what you had in the data before. And I think the key solution to that is really to understand, to educate people, to make it transparent. Even a deep learning algorithm can be understood to some extent. And once people will have understand how it works, and it requires education, it requires training, it requires young people in school, like the one attending this session, to really understand coding, algorithms, AI, and this will less and less occur.
Many thanks for this. Would someone else like to intervene?
So maybe I'll just say that obviously, the bias is ours. Sort of the bias is in the data, as Professor Bersini has said. We have various techniques to handle it, though. So one thing is that you have to make sure that the quality of data is high and that the representation of a given phenomenon within the data is high enough, right? So if you are, creating any algorithms that will be ultimately making decisions about human lives, right? I mean, you want to avoid discrimination as much as possible. So you should have robust pool of data that you're going to use to feed that algorithm. That's one thing. But there are many other techniques that are also within the algorithm, right? I mean, so kind of in the sense that within how the algorithm tackles the data, like feature inversion, right? So every data point has different features, right? When you think about the columns, for instance, in a CVS, right, CSV file, sorry, then you're going to have, let's say age and gender and other things. And you can try and play with that and invert that. Actually, that method has been used to some extent to kind of fool the algorithm a bit. By fooling, obviously, I'm using a metaphor here, right? So you can make sure that, for instance, certain aspects that we consider particularly sensitive are not visible, right? It's not going to always work, but in many cases, it will be a sufficient solution to reduce the bias, for instance, if we want to get rid of it, which we very often do. So, I mean, data is one thing. The other thing is like, what can happen within the model and how you're going to treat the data kind of within the model, what you're going to show to the algorithm and what you decide not to reveal. But that requires a lot of consciousness and ethical attitudes on the side of people who build these models, right? And that's why I believe that, for instance, ethics curriculum is very important in data science, because ultimately the people who design these models will be responsible for whatever they create. And I think they should kind of feel the burden of this responsibility. And also, I think in many ways, understand that whatever it is that they're building is going to impact people's lives, right? And then probably we can have results that are more satisfying than some biased systems that we've seen in the past.
Thank you so much for your intervention. Moving to the next question, we have a student asking, in what areas of our daily life is there artificial intelligence that most of us don't know about, but we should be aware of?
I'm happy to start very briefly.
Sure. Please go ahead.
I'm just gonna say that, weather applications very often are based on machine learning. Very simple techniques, but it's there. When you think about Spotify, Netflix, whenever you select music, right? I mean, or actually the music gets selected for you. Whenever, any platform offers you products or services, right? You have recommendation systems in place, very often based on clustering, very often based on classifications of various machine learning algorithms, right? So I think in your daily life, plenty of situations. There are plenty of situations. There are multiple situations throughout your day where you actually face artificial intelligence in various circumstances, right? So all kinds of platforms that recommend anything to you, products or goods or services, whatever that is, you may have a definitely a strong assumption that AI is probably there. Some form AI, sometimes less complex, sometimes more complex, but it's definitely there.
Yeah, and if you're interested in the history of AI, people tend to forget, and sorry if this is my age, but rule-based AI has produced an incredible amount of industrial applications. So it was not a failure. You have rule-based AI in a lot of industries, but people don't call even the rule-based AI, but just call it algorithms. But there are a lot of handcrafted rule-based AI algorithms. And when you use Waze, this is AI, just Waze, and most of the processors these days, they're using optimization in order to build the circuit in the optimal way. Whenever you have an optimization taking place, you have some form of AI. So the frontiers of AI are not well defined because there are a lot of connection with operation research, with statistics, etc. But remember that AI has been created exactly in the same time that computer science. So every type of use of computer algorithms, to some extent, if you go back to the history of AI, is AI.
Many thanks. Martin, would you like to add something?
Not specifically. I think the examples that Alexander was giving are probably the most relevant. Yeah, especially Spotify and Amazon. This is the most widespread today. Businesses also use it for designing advertising strategies, etc. But the ones non-business users, personal, especially young people, will come across mostly is with the streaming services.
Thank you so much for this. We will take another question from a student before wrapping up, because I'm afraid that we are closing. We're approaching 4 o'clock. So with your substantial experience on the AI field, what are your general expectations, opinions of the future and the evolvement of these technologies in our life?
If I can just say a little bit things, because we were discussing about the difference between Europe and, for instance, China and United States. And I guess that one really strong possibility for Europe, in fact, this was defending by Ursula von der Leyen. She visited the Brussels lab, I think it was before the pandemic crisis. And one specific focus she was, insisting on was the AI for the common good. So not so much AI for producing, for consumers or for, the private goods that we generally have, but AI for improving our living together. In fact, in Brussels, this day we have created the first AI for common good institute that I hope will be an example for other capitals in Europe. And we are trying to, exploit AI algorithms to improve our living together. For instance, to improve mobility in the cities, to make the cities smarter, to improve the energy transition, for instance, to make thermostat much more intelligent, to help people consume better and less energy, obviously to improve healthcare. So, for instance, there's been a lot of opportunity for software in this pandemic crisis, not always AI, but algorithms for deciding about who's going to be vaccinated, where, etc. So optimization algorithms. So a lot of algorithms can deal with the common good, what makes us all together happier living together. And this is definitely a place where Europe is much beyond United States and China, where this focus is not so much on that. So I fully hope that AI in the coming years will help us to live better, and less inequality, less discrimination, better healthcare, and energy transition, and better mobility, and this kind of thing. And I'm very optimistic on that.
So if I could just add something, I would say that, yes, agreed, absolutely. I think values will be very important. And who knows, maybe they can also become an unfair advantage, positively speaking, right, in the future, where you have this approach to artificial intelligence that makes sure that people are on board, right? That can also be a competitive advantage of some kind. And on top of that, I would say that what I expect is simplification in terms of interfaces, what I mentioned about not having to code, right? I think that's going to hopefully cause a situation in which there will be a widespread usage of artificial intelligence across different industries and by many different people who don't necessarily have to be trained in artificial intelligence and study data science, machine learning for years in order to actually gain some benefits from AI. So simplification, internal complexity, and simplification on the outside is something I'm probably predicting as a short-term future.
And to finish it all off with my prediction, I think AI will completely disappear. There will be no such thing as AI in a couple of years because AI will be everywhere, and therefore nobody will distinguish AI from other computing because it's going to be integrated with the rest of computing. And when as long as you talk about computing, you will automatically talk about AI, and therefore what we have today talking specifically about AI won't be possible anymore.
Many thanks. As we are approaching the end of the session, I would just like to thank all of you, especially the speakers, for the very interesting presentations, and also to the whole students and the people who are connected with us today and asked all the interesting questions. Thank you so much. We will definitely have more events on AI, part of the Connect University program. And we invite all of you to check the Connect University webpage on Futurium for similar events, as well as there you can read more information about the Connect University Summer School 2021 on Digital for Our Planet. The program is already published, and there we have already a session in the schedule that is dedicated for students as well. So thank you so much. I wish all of you a good afternoon, and see you at the next Connect University sessions.
Thank you so much.